Hello, everyone. So let's see what's happening today. YouTube have changed their stream, how it looks. There we go. Anyways, welcome. I don't have my usual microphone because of reasons. So I'm thinking that I've been doing some kind of stuff in, fixing some stuff in the Odin core library and also doing some stuff in the Odin compiler, and I think some of those things are fun to work on, and it's sort of fun to, how to say, it's the kind of thing that I think some of my viewers would think is fun to watch. And this is just me trying to essentially fix some GitHub issues that I've been annoyed with, and I just thought it was fun too. And I will at the end put in a PR, and then we'll see if it gets accepted, because I'm not a developer on the project or anything. So, I'm not a person in charge of anything, So, I've been looking at this thing. Hope no one resolved this already. No. So there is this thing. There's this thing with unions, right? Where a union essentially can have hold something of a type. This one can hold a raw pointer or something of type A or type B. And you can end up in situations when you sort of make when you sort of encode it as JSON and then decode it again, you can end up in situations where it can't figure out which one it's supposed to be, right? So that's what this issue here is about. It says JSON.unMarshal seems to be ignoring alternative structs in a union, because if it doesn't find the field it's looking for on the first struct variant it tries, it parses it as any value, skipping the other possibilities. We'll look at exactly what that looks like in the code. And what we have here is essentially, I think this one is supposed to be B. B is this struct. Okay, he has made a little fake JSON, like a test string here that's supposed to be JSON, and it contains an item that's of that has B, and B is this one. I'm not exactly sure about. We will make our own little repro case for it. And then there's some stuff said here about, so this is tricky to handle correctly because it has to do a best fit search, and currently it does the first fit search. Right. And then there was someone here who said that some JSON implementations put in a variant key, so essentially, because this one is called A and this one is called B, but there's nothing saying here which one this is. It just says that it has a field B. Yeah. Anyways, but I'm just wondering now, JSON are marching to B instead of A, but in this case it looks like, okay, let's take this one and see what his repro means, because I've seen this bug before, but this repro may be a bit uncertain about exactly what happens in this case. We will try that. But essentially, maybe you sometimes need some extra information in the JSON that you generate, because you can do what's called marshalling, where you sort of take something, for example, like a union, and you turn it into JSON, and then it sort of loses track of which of these types it currently is. It kind of guesses based on the feeds currently. And I was thinking maybe we can do something like, I've been talking about this before, I did a PR before, but something like this, where you have a variant, it says which variant it is, along with the data. But my initial idea was here to sort of maybe put the data block separately than the variant. But I was thinking, based on what this person talked about, that maybe we can just actually put in an extra field inside the data itself that has a impossible character such as $sign in front, and just say variant name, variant tag or something, and then use that to save some extra data about which one we expect this to be represented by this. So, but anyways, let's let me how do I best do this? Let's go to code maybe here. Here I have lots of crap. Let's open my classic playground project. Where is it? That one. Here's my numbers. I was trying steal things with memory. Let's close everything. Yeah, like that. And then I'll make this a bit smaller. Then we'll try his repro and try to figure out what is exactly what happens in his case. I like that it just minimized random things because I pulled this window to the top. I think it just moved this whole one to... Did it just move it to another... Where did it open? It just minimized everything. I don't even know what happened there. It's just like, oh, I'm just gonna minimize everything on your screen. Okay, there we go. So, here's my playground where I do silly things. I always do silly things in this. I like tab with 3. This is all just... Nope, nope, nope. Okay. Ah, okay, this was the whole program. And what build system is set? Okay, I guess it's this one. So what happened here is, this is some JSON, right? So this one tried to, it has the U here, which is a union, and it tries to unmarshal this string here into here. So it's essentially trying to fill out this union based on this string here. And that would... It has for some reason picked type A. Isn't that weird? Why would it pick type A? Because I've seen this happen with, like, if I have a union where I have like an int and an f32, right? And then I just say, let's see here. Let's make what would the value here be then? Because this is a whole struct. I guess you can't just do like 5. Yeah. Let me see here. What is we don't have core FMT. U is 5. Okay, that was funny. I didn't expect this to work, but it somehow, I thought there wouldn't be code in place to do this, but somehow it can take this 5 immediately and actually unmarshal it into this union. It looks at it. The question is, what is the type of it? So we can do like reflect. Let's pull in some more stuff here. Import core reflect. As usual. This is not even enabled. Union type variant type ID of U. Int. Okay. So here you could see, like, if I do 5.2, then it becomes F32. But if you spool down a 5, like on disk in a file, right? And then you've lost the information here, right? Because you're like, okay, was it an int or an F32? What was, because you could essentially have, we could make one, we could make like this. We can say U is a union of where we put in an F32 of 5, and then we could do like JSON.marshal any, this, we'll see if this works like that, and this becomes a byte stream, maybe. Yes. Oh, what's that, an error there? Yeah. Well, let's ignore the error for now, and we just say println string. So we take the bytes and we make it into a string. Okay, in that case it would, in this case it would actually work because it wrote down a lot of zeros. So I think in that case it would kind of work. Because then if you just take unmarshal data, so you can take this same bytes back. How does this thing? Some bytes and a pointer. Interesting. I thought this one was gonna become a float because it had all these extra. So, well, let's actually make a new union. We say U like this. Maybe this one actually failed even, I don't know, because I'm not checking the error. Print the error if it's not nil. Yeah, I was just being silly there. So this actually worked in this case. I guess, for example, if you have an F64, interesting. Question is, let's try to understand why this one does what it does. Because this person says that they expect this thing to be unmarshaled as a string, but for some reason, like, I bet if we do like this, we pull in reflect here again, union variant type ID of U. Then the type is A. That's very interesting. Why? Why on earth would it become A in this case? I'll look at this, what they wrote again. It does a first fit search, but how can this fit into, like, what is... Let me do like this, println u. How did something with a field called b, that is a string, at all fit into something that has... I'm gonna have to pull out a debugger and look at what this thing does, because that's interesting. Where's a debugger? There. Wow. Add a new target. We go up, up. Look at all this stuff. We go into... this is sorted in a very Linuxy way. Got that one. La la la. Ooh. Maybe that's a better way to do it. Yes. Okay, let's close all this. Blah 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 blah. And then we can step into this program. Wait, I don't think I compiled. Does this even compile in debug mode right now? Project blah blah blah. Nope, it does not. Just run it once to get the debug exe. Step into it. This is the rad debugger. Very nice. Funny thing is, you can use the step in. You can press step into function, whatever it's called, without the program running, and then it will step into the first line, which is the main entry. So this is the main entry in Odin, and you see it sets up the context, and then it calls the entry point. We of course want to go into the entry point because we're interested in all this stuff here. Okay, so that didn't work. Wow, 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 wow. Ah, there we go. I accidentally stepped out of it. So we try to unmarshal a string. The string is our hello p. Where did... Okay. Well, that didn't work. My debugger broken. Because it's supposed to get up here, right? Okay. Unclear. So we have our data. And then we look at this stuff. Make parser, blah blah blah. So we go down to where it starts parsing something. This debugging stuff seems broken. It locks here now and I can't do anything. I had to step out of it and step in again. Maybe I should update RAD debugger or something. Doesn't usually behave like this. Let's do that first. Didn't I just update it the other day though? We'll see. We'll see. Yeah, I think I updated it. Like, well, let's have a look. Let's have a look. Right. And then go back, we step in again. Stepped over that. Like, now I press step in here and it just steps into whatever this is. Some mem set. I guess it's some part of calling the procedure, but then it's sort of stuck there. But if I step out and step in again, then it works. Seems a bit sad to me. All right. So here's some union stuff. This is where it unmarshals a value into. So it's essentially whatever is the parser is looking at right now. It will unmarshal it into this value any here, and this value any is our union. This one, because we take a pointer to this one here and try to unmarshal this thing into it. So it's sort of parsing this and sort of trying to put it into there. This is one thing I would like to put a issue into RAD debugger about. Like when if you like go into some other window and you, oh, they fixed it maybe, no? No, but yeah, if you like down here and looking, then everything gets gray and it's hard for me to look at. So I don't like how extreme this difference is in the color. It should just be a border around the one that's selected, not to make the whole thing just impossible to look at, because you often have something on the side, you know, looking at it without, you know, without interacting with it, but you're still referring to it. Is this the thing that does the whole thing? So it goes through. This one checks, so this one gets the ID of this V, which is our union, and then it checks is the variant of is it a union on this sort of type ID thing, and it's like, okay, that's a union. So then it goes in, and this is some special code, and this is for maybes because there's only one variant, right? So maybe a maybe is a union with a single variant. And then it goes over all the variants in the union, and then oh yeah, this is a parser for this variant. I've been poking around in this code before. I might have written some of this. And then it comes in here again. And now it won't hit here because it's looking at the... It just tries to shove. Okay, so what it's doing it is going through all the variants from top to bottom. So we have this here, right? It's going through this variants from top to bottom. It's just trying to shove the thing in and see if it succeeds in doing so. So that's why it is... If it succeeds without an error, then it will say that this was good and assign the tag to the union. The tag is the number inside the union that says which variant it actually is. So if that works out, then it sort of goes in here. But if it doesn't work out, then it goes to the next variant. Right. So this one will be for the variant that's a raw pointer, I think. So we can look down here. Oh, yeah, the first there's an open brace because this one is parsing the text. So it's parsing. It's looking here now, and then it will look at, okay, we have B here. The weird thing here to me is that it should never be able to parse it into this struct because it doesn't even have anything called B. Is that? Should it still be able to? Like, just try to fill in the ones that, like, shouldn't it be an error? Shouldn't it be an error to try to parse a struct like this into, like if you try to unmarshal this stuff into here and there's not even a field with that name, isn't that an error? Maybe. So in marshal object is essentially for unmarshalling something with these curly braces. They can be represented in the Odin code by a struct or a union or something that it varies a bit. But the weird thing right now is, well, the confusing thing when you marshal something to a that is a union right now is that it just looks like a struct. So it just looks like whichever variant it currently held will be the one that's in here. This is how the JSON for it would look if you had marshaled something that had something where the current value was struct of type B on the union. Then it would look like this because it just writes it that struct down, and there is no information about that it is a union except that when you unmarshal it, the thing you're unmarshalling into is a union. So we have a union of type U here, right? And then we're trying to unmarshal this thing into it, which just looks like a struct. So we're just trying to fit in some of these. But let's go and see what it does, because I think it's a bit fishy that it even works that it somehow thinks it's okay that it can be this type, even though it has fields that where the name doesn't even match. But maybe that's, we'll see. Right, so we are inside unmarshal object. Unsupported type. Alright, I think this was... Yeah, the one we were looking at right now was probably the raw pointer type, of course, because that's the first one. So what... And this is the important thing to understand what's happening. Wait. So we were inside here, and I mean, probably this variant here was then a raw pointer, or whatever it's called. Let's have a look at, we can go here. Type info struct. Type info struct. Hello, Thundertastic. I'm not sure which type it was, but it was probably this one. Which one is that? Pointer is the 11th type, So what was ti dot variant Can I see? Oh, there's a tag. So you see 11. So that's what I was in here. I was marking the lines down to pointer, so I could see. I looked here how many lines I marked. That's a way to since a union has a tag that says the first one is if it's nillable. It depends a bit on if there's a nil or not. Then it's ±1. But yeah. So the 11th one is this one because I marked that many lines. I looked at the thing down here. Hello, Fantastic. Oh, the webcam is a bit over there, isn't it? It's a bit over there. I'm just trying to fix. I'm just investigating a sort of an issue in the microphone. Investigating an issue in the Odin core library with the JSON marshaller thingy, where they're both issues that I've had before, where things get marshaled into the wrong type. But then there's also this issue that's given here, and I'm just currently trying to understand why it is like it is, because I have some other good repro cases for this issue, but essentially it's that you don't save enough information in the JSON when you turn a union like this into JSON. You don't know if it's type A, raw pointer, or type B. You only know that based on the data you have. So in this case, you have this data here that it looks like a struct that has a field B with value hello. So it should be this one, but for some reason it thinks it's this one. So I'm just trying to understand why it's like that for starters. But then I have some other issues I've seen also where you can have like we could essentially have an integer and a F32, and it's a bit ambiguous which one it is. If there's a 5 without any decimals in the JSON data, for example, because it can't identify which one it is. Although I just noted that when I do marshal it, it writes down the decimals. But you could also you can hand edit data quite often and be like, okay, I changed it to 2. So I changed it from 5.0 to 2, but I still want it to be a F32. But yeah. Where was I in the debugger? Right. So we verified that this was the what's it called, the raw pointer. So this one failed, but that's so now we get here. Now it will have the variant is 1 here. Well, that's the index of the variant, but this variant is this variant here. So it's going through, this unmarshal is going through first this variant and then this variant, and it's trying to fit this string of data, unmarshal it. Well, JSON doesn't, you can write a number without a decimal in JSON. That's totally fine. So there's nothing in JSON saying what the number is at all. I mean, you just write something down in JSON, and then you can parse it on sometime later, and then exactly what that data is interpreted as. In this case, I mean, we are representing structs in a programming language. It just used as a way to sort of organize the data, essentially, right? So now we will get into this one again, because we're just using the same data over and over. We're just using the string with the We're just using this string but trying to fit it into the different variants over and over. So now I think it will succeed. But I'm a bit... Okay, so it's inside here now, and it's like, okay, it's a struct current token. Yeah, so here it's going. It has removed the opening brace, so you can see here that it's here now. So it has the key is B. Okay, good. Unmarshal expect token P colon. Yep, good. So that this will have eaten the colon now. So now comes the string. So fields reflect struct field zip t.t.e. Yeah, so this struct only has the field A. Hello Marcy, this is the RAD debugger. I will link it to you. It is currently alpha software, but it's from RAD software owned by Epic, and it starts in less than a second and can debug C and Odin and stuff. It's sort of alpha, so it's a bit. I already have some problems on the stream with it, but I really like it. I think this debugger is gonna become. It's the future of debugging in C and Odin. I really think so, because it starts really quickly. Well, yeah, okay, that's just a bonus really, but and it has all the kind of things you need in a debugger to sort of keep track of complicated things. You have all your different kind of breakpoints and watches, and you can look at your assembly even if you like, and everything is just very like all the features you kind of expect from debugging in Visual Studio, for example. But it's just so snappy. I think it's very fascinating. I'm like, this program looks a bit different, you know. It clearly has its own UI rendering, and I'm like, okay, what has it done? Why is it so snappy? And then I looked into like the source code. I'm like, oh, it uses a direct 3D renderer, so it uses like fast GPU rendering to draw this. That like it doesn't even use any of the Windows stuff. It just goes directly, and I haven't looked into it, but I'm guessing that it's creating a. It just uses GPU acceleration to draw all these different things into some kind of canvas, and it has defined its own UI system somehow. I don't think it's using dear GUI. I think he's using a immediate mode UI, but I don't think it's there, because I can always feel when it's DRM GUI, because it's DRM GUI can be a bit laggy sometimes with like these kind of interactions are so fast. Like DRM GUI has more of frame delays usually. So yeah. Right. Yeah, it is very fast. Anyways, what are we doing here? So we're going through all the fields. So it has field A. JSON name from tag value. What's this? Okay, that you can have a tag on something in Odin, so it's you say what it's supposed to be in the JSON. Eden asks, is this issue caused by how missing fields are handled? Well, we're trying to fit something that has a field B into a struct that has no field B. Well, he wrote it in C or C++ maybe it is, but it's a very C-ish C++, so it's but yeah, that's just what Ryan Fleury does. But anyway, so The question is this issue caused by how missing fields are handled? Well, what is the correct thing here? If you have JSON with a field B and you're trying to unmarshal it, like put it into a struct that has no field B, does it just skip that one? Or does it say this is not compatible? What's the correct thing to do there? And maybe it should error, or if you have a struct called, if you have a struct with field A and B and you have put that data onto disk, and then you in your code remove field B or A, then your data would suddenly no longer be able to put in there. So I think that's actually quite bad. If you, Billy said that this trick to handle it correctly because it has to do a best fit search, and it does currently a first fit search. In the case other struct, a missing field might be an error, so we just get right. In the case of other structs, a missing field might not be an error. Yeah, so he sort of mentions that. You are correct. Because it might not be an error. Like I said, you could have removed it. So he means if there's a missing field in the, I think he means in the Odin struct. So you have some data, and then you're trying to put that into something, and it's there's a field that's not available in there. But that could just be that your data is for an old version of that struct that where you have on the Odin side removed that field, but you still want the other fields to come in correctly. And it is tricky because it's you can't ignore that one really. Anyways, so I understand why this is like it is, and so if we go back, if we shut down this debugging session and look at this again, we look at our code here again, I'm guessing that the value of u is just a with 0. So it just saw a struct here, right? And it tried to put this struct into A. B wasn't there, but that didn't stop it because it could still, like, oh well, it was still a struct. I just didn't have all the fields for it. I mean, in this case it had 0 of the fields, but yeah. But what I'm thinking for this, perhaps, what should happen here is that my cable is really tangled. Wait. There we go. Yeah, so there's no, Ethan says, there's no error when the struct is missing a field or when the JSON object has a field or the struct doesn't. Yes, correct. And I don't think that should be, it should probably not be an error, because say that you didn't have a union at all. Say you just had like this one. All right, A and B, and we say that this U is of type A, and then we say we have A, and then we have B. Oh, now I have to type. I always use the simplified JSON standards. A is 7, B is hello, and then we remove that line so we can compile. Yeah. And then we do fmt.printlnu. Here you see, this one took this data here and successfully marshaled it into this thing. So imagine you have this data on disk. This is in your JSON file, and then you have done this. Now it still works because I just have like, oh yeah, I don't want to have a int on here anymore. If this will suddenly make it so that this no longer parses correctly, then you have to go in here and sort of go through all your JSON, migrate it, and remove that one. That's probably not what you want. So that's why what happens is correct, and it is. So if we undo the whole of everything here, so we're back here. So that's why but anyways, so my idea for all this is that whenever you see a union and you marshal it down, so this is a fixed string here, of course, but whenever we marshal a union, we let me type this as our mock union data. Okay. So say that it is something like this. This still works, right? Yeah. So if we instead had something like this, where it said variant name is a string. So in this case, we would expect it to be B. So we have that. And we also, whenever there's a union, we write down both the variant name and the variant tag. Tag in this case is, this is nillable, so tag 0 is nil, 1, 2, I think. Like that. What it would do now is whenever it's trying to unmarshal a union, it will first look for the variant name. Like it will, the reason this would have a $sign is because it's illegal to have, like you just choose something that's invalid Odin here, right? So you use this, and then you see, oh, there's a variant name here. Then you go through all the variants and try to pick that one and see if you can do it. If you couldn't do it with that one, then you see, okay, but we had a tag also. Okay, then we try with that one, and then we use the variant with the tag, and the tag is then this nil is 0, this is 1, and this is 2. Wait, but this should be B. With a nillable union, if nil has 0, this has 1, 2, 3. So this should be 3, I think. Yeah. We can double check that. So the thing this would do then is that whenever it sees a unit, it writes down this extra data. And if none of this exists, then it tries to do what it did before. But if this exists, then it tries to like, okay, I try to use that variant type before I do anything else. The reason you would have a tag also is because if you have renamed this to Bob, then this would no longer work. But at least it has the fallback of the tag. It's like, okay, 0, 1, 2, 3. Okay, Bob. Okay, so we tried that one. So we try that one first. If you have both renamed, the tag becomes invalid when you change the order of things. So it's best to use the name first. You check with the name first. If the name doesn't work, then you try to use tag. If you have both changed your name and the order, then you're not doing so. Then that's not so good. But then you've really messed up, right? It's good to do one thing at a time. And if none of these succeed, then it falls back onto trying to use the first fit, what it does from before. That's my idea for like, because trying to do a best fit search, I think is just, it's still gonna be, it's like you had my example from before. If you have f32 and int and you have a 5, your value is a 5, 7, say, like which one of this is it? Because it could be that I have hand edited it, like the data somehow, so there's no decimal in there, or you could have something like an I32 and an I64. Now it's impossible to say which one it is, because it's yeah, that's impossible. So that's my idea for a solution to this. So what we could try to do is first write out this extra stuff here. Or is it best to, maybe we start with, since we have all this, maybe we can start with the parsing. Maybe that's better. I like that I tried to use, I didn't use this one before, I just Does it need to be like that, maybe? Oh, silly me. Bob. Yeah, so there we go. Now it's still making it into an A because it couldn't fit. That's the best fit it had. Well, it's the first fit it had. It fit into A because it was a struct, and sure, I think if you had a field called A, if you had a field called A in here that has a string value, hello, then it becomes B, because then it tries to, okay, I'm amazed at this even. This makes sense because it tried to unmarshal it into A, and it had a field called A. It's like, oh, they match, but then the thing here is a string and it's supposed to be an int. So this becomes an error. This is an error because this data is not compatible. That makes sense. And then it went on to B. In B, A doesn't exist, but B exists, and it's the correct type, so that worked. But this one, to the user quite strangely, becomes like this. Right. So let's try to maybe use this data here to, because I'm pretty sure if we, can I just print the tag ID of, I can print that and reflect dot raw tag u2, and it's A, so 0 1 2, yes, correct. So if we go into here then, let's see what we can do. Unmarshal value. Okay, now comes the funny stuff here. And I have done stuff related to this before. This one makes a copy of the whole parser. Variant P. Okay, okay. What can we do here? Because we're looping over the variance, right? But we almost want to first check, is there a thing inside the actual data that says, is the data sort of a, if the data isn't sort of looking like a struct type, I just realized something. Like if you have something like this, then there's no struct anymore, so it doesn't become backwards compatible in that case. Because here we have f32 int, like if your union looked like this, ignore these things up here, then the correct value for this one currently would be like 7, for example. But then there's no, it's only if it's a struct or something, or like you say that it is an array of f32s, then I think it will look something like that, or maybe it looks like I think it looks like this, maybe. I didn't think of that. Otherwise, this would have been very elegant, but I was a bit stuck on it, thinking of it as a struct. Because if it's a struct, you can always put these extra things in here. But in this case, I mean, of course I would like it to be like, I want to know if something is an f32 and which tag it has. But then I have no place to put the value. I mean, I can of course do something like this, but it's not backwards compatible because the old data would just be like this. For a struct, I could do it backwards compatible. But I really don't feel like the best fit kind of stuff is what you want. Like, or it's still so ambiguous. Like, it's just, even if you have best fit, there needs to be some way to kind of record more precise data about what the thing you have saved is, I think. The other idea has been to sort of have, because you have this struct, right? This is when you write something out to disk. So maybe we should start with writing something out instead of. So we have u. U is a union, and we give it a value of b, and we say b equals hello, and then we say date bytes JSON.marshal u, right? Then we can print that. We can remove this mock stuff because we will have something. And then we can just unmarshal this bytes instead. So here we have the exact same thing, but we've used a marshal to make the data and then unmarshal it. Oh, this one even got. Oh, yeah. This is because I reused the same. That's funny, doesn't it zero the memory of the variable? Is this a bug maybe? If you unmarshal into this thing. So what has happened here is that this one used to be on this tabs are. This thing used to have the tag for a B. And it had, and then unmarshal went in and like, oh, I think it's an A, and then I just changed the tag. But since it never found a value for A, I think there might be a bug there that if you unmarshal into something, shouldn't you then zero out that thing? Or is that silly? So this is the stuff that because it never manages to set any data on A, so it will just be the memory from the old string there. I mean, what I should do here for my testing is I should have a separate variable for the re-unmarshaled one. But this one just changes the tag on it, and then it has never been able to It's a bit tricky because I can look at that separately later. One thing at a time. UA as in you unmarshaled, or rather we can do this maybe. Call this one UM as in you, and then we marshal it, and then we make a new one called U of type U. It's all zeroed out, and now it's like it's correct again. So there is a bug there where it doesn't clear out fields properly. I think, well, we can discuss if it's a bug, I guess. But so you have this thing here. However, if you have a 32 and an integer, and then you just have like a 32 5, then of course what is marshaled out from this one is just a single 5. There's no longer any information about what that thing is. But I was thinking that maybe this is a bit, should there be a setting on the marshaller to write union type data, union tag data and stuff? Because you could have an option in here that says like always write union type data or something. Then it would do that. And then the unmarshaller, when it comes here, would of course be able to look at the thing it's getting, at the thing it's parsing, and be like, okay, if it does look like an object with curly braces and stuff, then I try to fetch out the data, and well, then I try to fetch out the thinking if it can be a bit this. I guess if you make it so that the thing this one looks like an object, but it has like a variant name and variant tag or something on it inside the object. If it looks at an object and it sees that, then it's like, okay, this I should try to use. I should try to unmarshal as using that kind of extra knowledge. And if it can't find it, then it just goes and does the old stuff. So it's backwards compatible in that way. So it just, if it sees a struct-like thing in the, or like a JSON object with either the variant name or the variant tag or both, then it sort of says, okay, I'm gonna try to do this kind of matching, and here's the info. And goes and does that. Otherwise it falls back. And then that way the unmarshal doesn't need any options. It can just look at the data and see what it is. And then the marshaller, in the marshaller, I guess you would turn it on maybe. So let's maybe try doing that first instead. Let's just do like this. We comment all this out. So we just see what it did, and then we add in an option. What's it called? Opt. So this option, marshal options. Let's add a thing somewhere at the bottom. Write union type union variant. I don't know what to call it. Write union variant info or something. Say true. Cool. Okay, and then we go into Marshall. Don't be I just think of the old small video game. It was shouted, "Don't be a fool, Marshall." Builder make blah blah blah. Marshall to builder, builder to writer. So, and down here I think it will say if it's a union. Right, here we go. You come to down here. Here it figures out the tag. What does it do with this tag really? So this is where it sort of turns the Odin union into JSON. If it's nil or there's no variance, then it says null. Okay, that's fine. This thing, well, this might not be fine, and if it's yeah, we'll see about this, because if we put this in and we have a nilled pointer and it should be have tag info blah 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 blah, might be wrong, but ignore that. So then it just fetches the current tag. And this is quite funny. If the info says that this one is not nillable, tag any. Right, this reduces it by 1 if it's not nillable. Because if it is nillable, then the 0 value of the tag is used for nil. It's not no nil. Okay, that means it's nillable. So this one is. Oh, okay, I see. What it does here is that if it's nillable and it is nil, then it writes null. Otherwise, it writes the tag -1 because nil is covered by null here. So then the union variant with the nillable, that is the nillable union variant as tag 1 will become 0 because it can handle nil using this instead. I guess it makes the data slightly easier to work with because you can always start at the top and count. The first one is tag 0, 1, 2, blah, 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 blah. Like it sort of, maybe it's good. It does make it, because that's not really what happens inside in Odin, because then in Odin you have tag 0 is nil if it's nillable. So, but yeah. Oh well. And then it tries to write, it makes a new any using the data at that point, and then just changes the ID so that I think when it comes in here, what will happen here is that it will get into the struct variant instead. So it would be like, well, if it is a struct, it will look at it like a struct. Otherwise, it will look at it like something else, like an int or whatever. Let's see up here. Info, blah, blah, blah. What is this? Map struct union. V. So V is the thing that comes in. I guess that the data of a union is just the data of the variant then. That's what it means. It looks like. Because you can just take v.data and throw it in here. So what we essentially need to do here is, do we have the opt available here? If opt dot, okay. Let me see. Oh, maybe I didn't save that. Write union variant info, okay. If opt, yeah. If we have this, then we essentially need to write it like a, I'm not saying it should be here, it should probably be up here somewhere where it does this stuff, but it probably needs to add in the curly braces, the tag name, and the type name, the variant name and the variant tag, and then it needs to make a new field called data where it writes out the stuff. What is this? Where can this? Okay. So maybe it's just do this one step at a time. Maybe it's just about here you can write null. Right. v.data is nil. What does that mean? Okay, that means the data itself is nil. Maybe, and down here we have that the tag is 0. Let's do this. Then we write the ending here. So you see now this was on, so it wrote out these two curly braces. Okay. Interesting. This is all, I'm gonna have to work on this in a bit, like do a bit and then figure out the issues and then add in some more stuff. How do I write the indentation? Opt write iteration. Insert comma separation and write indentations. Right. So what does this do in the case of a struct? It okay. This is just for adding in the comma and the white space. Let's just try to do this. We write through here. We can move this to down here, I think, instead. So we do that. Oh, this one is fix my Sublime build system here. Project here. I couldn't build from inside here. Still couldn't. Project path. There we go. And I guess after that, I'm just trying my luck here. Opt write key, and then I write variant name. Yeah, there you go. I mean, this is not supposed to be like that, but it just, I'm supposed to write a value there as well. What does opt write key? Okay, yeah, because how you write keys depends on the options. That's why this opt write key is like, if you're using this type of JSON or this type, then the things will look different. Eden asks, would you also write out a variant info for null or just write null? I think if you have a raw pointer and a pointer to an integer, then you would have to write out the variant info, because which null is it that you have? I think there might be we'll see if we end up in trouble here, because yeah, I will look at that a bit later, because I think depending on what you feed in for the union, it might be a bit like maybe you hit this one where the data is nil, and then you can't get the tag pointer anymore. Yeah, I'm not exactly sure how that works. I will have to play around a bit with that to figure it out. Okay, so now I would essentially need to write a string. How do I do that? Is it this one? We'll see. We go into Marshall to writer and look at how it writes a string, and then we do something similar. Okay, just as this. Which one we want? This. Right, quoted string. Which one did I take that from? Wait. Was that a null I stole it from? Right. Okay, yeah. No, it wasn't. The string is this one. So I write. I would need to write the variant name somehow. And that's of course on here, I think. Let's have a look at info. Variants, type info. Info variance tag. Oh wait, what is? What is info? Info is it's a union. Type info. Well, of course I knew that because it says here. So we have the variants. The variants are a bunch of type infos, and they have a type ID. Hello, Lucy. Yes, I'm trying to investigate an issue with how the JSON writing works. I'm just trying to do a bit of explorative programming and see if I can come up with a nice solution that is both backwards compatible but also a bit more powerful with how you write unions with variants and stuff. But I am type. How do I like, I know there's a named. Am I supposed to check if this is a named type? And then write out the name? No, I think I'm supposed to take the type ID. Type ID. How do I get the name of the current type? Like a string. that's my main. Like if I just do this, that's just an type ID. I mean, okay, I'm just gonna. I know I'm not. It's not how I'm gonna do it. I'm just gonna write this, see what it does. Okay, that doesn't work, of course, because you don't have FMT in here. Can hack it in for now just to see. Temp print variant name F32. Okay, good. So that's what it wrote now. Oh, and I guess if I wrote like this, pretty, it's true. Yeah, then it does this, all this stuff. But that's for if you need it, if you want to turn it on. But I can put that on, so I see that this write iteration does this nice stuff if you have that pretty printing turned on. Right. Now the question is, how do I get the name of a, I guess, reflect. It's a bit interesting this, because it feels like some of these things now you could use reflection for. Because here it just says blah 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 blah. Is there like a variant? How would I get the name of the current one? Okay, let me check something here. Because this is not how I'm supposed to do it. I'm just type info. I've forgotten how. I've done this before, I think, but I'm forgotten what the most best way is. Question is it named? You can check. Ethan asks, how would you handle anonymous structs? Yeah, because I guess, let's check what, because I guess you can do like this. A is a string, B is a int, is, well, oh wait, of course you must say struct here. Struct. Yeah, and then we say anonymous structs and unions are a bit funny, because how would I assign to this thing? I guess I can do, is this like, how do you can you do this? Oh, I love that. It wrote so you can actually do that. I think you need that because it's on a single line. Well, with anonymous structs you can't write the type name. Really? There's no variant name. There's just a type there, but you can still write a tag and use that as a fallback in that case. But like, so this is 1 and 2 in this case. I think that should still work fine. I mean, if you're using a... Yeah, I think that should be fine. But it's an interesting question. Something I need to test. So we have these. And then we marshal. Okay, now I need to figure out how to get the variant name here. I seem to have like this one is a type info float. Right. What is this thing? As a tag, this is an any. The pointer inside the any is the pointer to the tag itself with an ID of which type this tag actually uses, and this is the type that the number that's inside the union actually uses. Question is, am I barking up the wrong tree here? I'll see. Because you have some data, and then you're looking at the type. This is easy to get confused about. What does this one do when it gets something like this? This is like, okay, I saw a float, I'm gonna do this. Wait, go back. Verb. FMT arg. How did... okay. So it tries to format any value. I'm just trying to see how fmt.tprint does it to get type ID base. So for an F32, no wait, I'm being silly here. I'm looking at the wrong thing. This is the type info of the thing. This one should print looking at the type info itself. Type info. the thing I'm sending in here, right? Oh, it's a union. Has a bunch of variants. Take the current variant. Take the current variant. And that's just a type ID. So what? Okay, yeah. Let me look at that again. T print. Does SB print? Does W print? Does FMT value? Wait, did it? Yes. Then it does. Comes in here, and it's like. It's this one. Type info, type ID. Type ID. Right, type ID. This is what I was interested in. How does this work? Well, I don't really care which one of these. ID. Right there. It does it. Sort of does it all manually, but that's fine. Because now I see what it does, so I can be like, go into here. I can probably do something like this, right? Because I have a writer here, don't I? So I can just reflect writer, blah blah, W, take the type ID. What the hell is this thing? Num written. Nil, I guess. I have something I can use or return here because the. Maybe I can. Oh yeah. Ugh. Write quoted string. Write. How do I? That's a quoted string. That's good, but that's not really what I need. What does this one do when it tries to write a type ID? Guess maybe it doesn't. It doesn't make any sense to marshal a type ID usually because. Well, I guess it would make sense. You could write a name. Union, there's the struct, there's the info slice, dynamic array number field, type ID, unsupported type. Yeah. But we can figure that out. Okay, let's just go into this thing instead and be like. There must be something else that writes a quoted. Fuck it, I'm just gonna write my stupid quotes myself. or return. Here you go. False. Put in a comma there. So this thing puts in comma. For the first when it's true, it just puts the indentation. But in the second one, it will put in a comma and indentation because, of course, for the first one you don't want that. So then we have figured out that. I'm gonna look a bit. This is typical. I will look at how to do this. There's a better way to do this because this one figures out how to write a type ID, but I don't know if I can easily put it in quotes easily. But doesn't matter. So we put some variant name and then we write a variant tag. And then we just, this one is easier because we just io.write int, I think, tag, base 10, all good. Oh, I don't think we needed to specify nil over wherever we're here actually. Oh yeah, just this one. Yeah, let's do that then. Boop boop. Some more iteration. We wrote the tag, it's 0, is that correct? Let's go have a look. Well, is it correct? So the union can hold an F42 or an integer. So we wrote the tag 0, but this one is nillable. And this thing removes one and just writes null instead. So the tag is really, how do I then represent, if I do like this, how do I represent something that is null? Wait, it's a bit funny, right? Because you can have a variant that is null, like a pointer inside a union. So we can actually try that, see what happens. Pointer to an F42. Well, okay. Also, writing out a pointer is what does it mean really? But I'll write a raw pointer. See what happens. So this is a pointer to a 5. Oh, sorry. F23. I always type F23. It's my favorite type. Wow. He did not like that. I didn't write anything. Well, maybe I should check my error. Unsupported type. Not so weird. It's a pointer. So maybe that's I mean, it doesn't make any sense to try to write out a pointer, right? What does it mean when you unmarshal it again? Unmarshal a memory address. Oh, okay. It points to some random garbage. I mean, of course, you could try to marshal the thing it points at. Does that work, by the way? What happens if I do a pointer to B? And do a B here. B equals hello. My B. And support the type. Yeah. So it doesn't handle that, but I think this is... If it did handle it, then when you unmarshal it, it would need to be like, okay, I'm just going to create... It's going to have to make assumptions about how to create the objects and stuff. So yeah, it's not very useful data, I think, when it's also for example... Okay, what happens if I do this? So make this an S. My S. It's an S. It's a pointer to... Why do I call it my B? It's called B. And then I set this one to be S. So I do this. Wait, no, like that's what I wanted. And then I do this. Yeah, unsupported type. But that makes sense. So if this was B, then it would be like, ta-da! Anyways. That was just a little aside. I was thinking about what happens with pointers and stuff. So if you had a... So if you instead set this one to nil, remove all this funny stuff, what happens then? Then it's just null. Which is fine, because that means the whole union is nil. You don't have a tag. That's all the info you need, really. So that's okay. I think that would be... I think actually this might be fine up here. So if it's not null, then we do all this funny stuff. Okay. Let me get my stuff back. F32.5. Okay. So now it writes the tag 0 here. Is that correct? Yeah. We're gonna say that it's correct because null is handled by it being null. So we say that's 0. We're gonna be okay with how it does stuff here. So in that case, we just need, like, we can just have an else here essentially. Okay, actually we can just write the whole shablam like this, and else we do this, remove that, and now we just go like data. Yeah. So this is how we wrote a 5. If this is turned on, this is an option to turn it on. Then it will write. It's nicer, like it will stop guessing. So if we return to this, I think the original example was like this, with a B here. Then we have A, yeah, we have to make this into a B, and B is hello. Then the variant name now, the variant name on the field here is B, and the variant tag is 2, 0, 1, 0, 1, 2. If we put no nil here, then the tag is still 2, because that's how it works. So that's because that's since it subtracts 1 from the tag when it is nillable. So it sort of wrote what I expected now. So now we could I'm gonna take a quick break. Visit the men's room. Be right back. Hello. Let's try to unmarshal our funny stuff now, see what happens. I mean, this is gonna explode now. But that's fine. And it's funny, this is what happens now is that... Wait, is it even using the bytes? So we have our bytes here coming in, it unmarshal those. Okay, good. So it's looking at this and it's trying to... Currently, it looks through the variants. It comes to A and then it says, okay, it's a struct. This also seems to be an object, which is a valid way to store a struct. So then it goes through all these. It tries to interpret this as a struct field, and none of these match, but it was still a struct. So it's like, okay, that's fine. Maybe someone just removed all my fields. So that's fine, really. What we should do then is go to unmarshal here, and here this is where we started for a while ago. And now we need to do some shenanigans. Let's see if I can even do this. You know, everything might fall up when you do stuff like this, because you need to do it one step at a time. Sometimes you work for 2 hours and then you realize I can't continue because I can't get the stuff I need at this point in the code. But I think, let's see. Let me see here if I can unmarsh. Well, I don't want to unmarshal an object, but I kind of want to yeah, we'll have to right. Let's do some funny stuff here. Let's just check if if token.kind equals .open brace, which means that the thing we're looking at, I think this should still compile, right? Yeah. So we're there. We got this stuff. Then we can go to, I'm gonna need make this a bit smaller. Go down Marshall again. I'm optimizing my screen space here. I removed the line numbers because I don't want too small text on the stream. It's no fun. On Marshall. What's it called? So you have an open brace, then you unmarshal an object, right? Ethan asked, would you do special handling for the built-in maybe union? Yeah, in the writer I can do that because it's so simple, and then in the unmarshaller there's already this is it. If len variance equals 1, you're not allowed to have any other union with only one variant that is also nillable. Wait. Yeah, I think something like that. But anyways, so if it comes into here, then it's this is the maybe stuff. So I don't need to touch that right now. So we'll see. So there's some funny stuff I need to do here now. I need to essentially do something like this. This is like this is where I check the object with the yeah. I don't want to call it check p. And so I copy the parser, so I get my own parser because I will mess with it a bit in here, right? And essentially I need to do the same stuff as a struct does. If the token kind is not end token, I think this is in the end token because sometimes you can have a struct that runs without in the root scope to the end of the file, but without the braces. So that's why this might be end of file instead of close brace. But that's fine. What does expect token really do? Does it advance it also? It does. Okay. So we could just essentially do this then. Wait, we need to here. We need to do this, and then we do like we skip over that one. Good. I'm gonna do the classic hide the taskbar. Wow. Annoying. Give me some space there. I expect an open brace that will make it pass over it in the parser, so it's no longer there. And I don't care about this stuff. I don't care about what this is for this is for trying to parse something with a curly brace into a struct. I'm just gonna look into the thing in the curly brace and see if the info I want is there. So I will just try doing this. Dot close brace. So So if check p the current token of kind is not close brace, then we do this. We loop, loop, loop. Well, we loop as long as this is not true, and then we parse out an object key or allocator. Okay, I don't really need to allocate this, but can I? This is temporary, so I don't need the allocated version. Because I should be able to just get the key without allocating here. Let's see. Clone string talk.text. Right. Uncode string key allocator talk. Yeah, expect token string I think is a yeah, that's a token kind string. What does this one do? Quote blah. Takes out the string. Unquote string. What if I don't want to allocate it? I don't even want to temp allocate it. I don't think it's necessary. I just want to check, is it a string? If it's a string, I always want the key there. I just want the key there. Expect token. Okay, what does unquote string do with the allocator? You can return the clone string. Got dark in here. Ta-da! Clone string. If I is len s, then it clones the whole thing. Okay. I will fix that later. I mean, before and if this is done now, that would be fixed. But I need to look a bit into the fetching the actual key. It should be possible to just make a version of this that checks which specification we're using, and then we just either we expect there to be a quote or not, and then we take the thing up to the colon or whatever separator we're using without an allocation, just for a temporary like look ahead check like this, because this stuff will not, this is only for temporary stuff in here. It will just use the data in the parser. Right. What does this compile now? Okay, yeah. If let's just print the key. Yeah. Let's include the FMT just so we can do some debug funny stuff in here. We just hung the. Let me kill the program quickly here. What's it called? Playground. Bam. I know we hung the fmt.print blah blah blah. This of course needs to continue doing stuff. Expect token. Sure. And then we just try to we just check maybe if let me just break here and see what we got. We're using the wrong parser. I was like, what's going on? This is gonna be troublesome to have two parsers. It says variant name here, which is what I sort of expected. So I got the variant name out. So now I can say here instead, I'm just gonna keep the break there, so to kill it after the first one, so I can work on this and then add in the rest of the loop. If key is variant name, then we do something like parse object, no, parse value, parse value. What does, can we make this one I just want to parse a string now. Like I said, I don't really care about this. Is return unquote string. Okay. Right. But that's not the marsh. Wait, I'm being stupid here. Unmarshal value. I looked at parse value. The parser is just for parsing. Isn't that? Wait a minute. Wait a minute. Can I just parse the JSON instead and look at it? Am I overcomplicating this by like writing a tiny parse value? Oh yeah, of course, then Marshall uses the parser. I didn't think of that. Okay. So if then, if it's an open brace, then it parses the object. Okay, so maybe we can do something much nicer here. I didn't think of this at all. Let's try this. Parse value. Then we send in this check P we got here. Send the lock if you really want to. Of course, this one might again do. It will again do some allocations, which is totally unnecessary in this case. But you know, we'll see. Yeah, this one returns an error also, doesn't it? Just print that one, check what it is. So I'm just, it is very explorative, you know. I'm just trying to. So here you see, what I got from parse value here is data and my stuff over here. Although I can't really use this data because the marshaller needs to continue using, like, for the stuff that's actually the data, it needs to do the sort of default stuff it should do, really. So maybe using this in this case is not that good of an idea. We'll see. Maybe I'll return to that later, because now I know I'm at a variant name, so I can be like, I can parse a value at check P and I can say v variant name r if variant name r is nil, not nil, or rather I should probably just, yeah, I'm gonna use an or returner later. I'm just printing here for my own uses right now. There is a B, and I think that's the so much printing going on here. So yeah, so successfully fetched that one. So that's good. I don't. Yeah, and then parser value goes in here and parses using the allocator. Yeah, I'm gonna have to come up with something here, because I mean, it's doing stuff that's not usually done with this code. I think because this one does lots of UTF-8, like it makes a looks at how long the string is and does some stuff. And what does all this do? BFR TNU. Right, this is for when strings have like escape characters and stuff in them. Because if there is a backslash, then it looks at that and sort of tries to do the correct thing and blah diddy blah. And but that's not important in this case, because there will be no escape characters and stuff in these things. It will be a string as a type name, or it will be, for the tag, it will be a number. So we can probably get away with something simpler there, but we can look at that in a bit. So we got our variant name. So this means here we have maybe we can, should we do like a maybe here? Maybe a string. Variant name. Expect variant name. Is that the correct term to use? Expect variant name. Maybe. Of course. I think you can do like this: variant name dot string or return. Does that work? Bool to unmarshal error. No, it doesn't work because this, it says bool if it worked. So this, but maybe none of these are actually errors really, because call this something else instead. Whatever. Right. If it was a string there, then we set it. All good. So down here then we can say fmt.println variant name is b. The maybe is, well, the maybe is set. And then we can of course do something similar where we go and be like else if key is variant tag, then we say variant tag val, expect an integer, if parse integers is turned on that one. Wait, is that on the parser? Parse integers. Yeah. Let's tell it to do that, because otherwise everything becomes floats. That's probably why my example from before, maybe I think I tried to replicate something and parse integers wasn't on, but never mind that. variant tag is a maybe of a I say I64 because that's the biggest one we can have on a tag. So we say we cast it. What is it called? Value on a JSON. Yeah, there is called integer. Yeah, variant name, variant tag. Okay. So now we have like nil. Yeah, okay. What did I call it? Variant. Because there's a break here, of course. I think I should just parse the value here and then maybe do like this. Then I can remove the break because then this will just loop through all the stuff. I think. And Marshall expect token. What went wrong? How far does it get? Variant name. Then it's like, nope. Oh, I guess parse value does not. Wait. Unmarshal value. What does it do really? Okay, that was the one I was looking in. So if I have unmarshal object, what does it do? Like for every parse comma. The key colon fields structure is safe. Okay, but that's just the fields inside the thing you're parsing into. Just looking at what the normal unmarshalling for structs does. So if you found the field, I think I just need to parse comma because I guess that one will allow token comma. Do break. Allow token, blah blah blah. Okay. Interesting. So we parse out the comma afterwards. Of course, that's what we need to do, because it could never parse the next key because there was a comma in the way. But this thing says false if okay. This one is like break the thing. If in this case, if this was the case, but what does that do really? Struct loop just breaks, comes down here. Token. No, I don't think that. Okay, yeah. So the thing it does is, you're correct that if there's no comma after the last one, then it's done. So what happens then is that it breaks the loop. But if there was something after it, then that would be like a parsing error, right? Because it would find something unexpected. So yeah. So here we need to be like unmarshal expect token check p dot close brace struct loop. Oh, this is not struct loop. This is just like var whatever check p loop. I don't know these names. So now if there is a missing comma where it wanted one, sort of in the middle, then it will break out and then it will expect a close brace there, but there wasn't one. Maybe there was a key instead because you missed a comma, so then the errors will be okay. So that's, and there you go. It says variant name tag data. Okay, good. And I can remove that printing. So we have variant blah blah blah. So then down here, and now we have the funny thing here that we always need to, this is the fallback, this is the first fit, this thing here. So if either of these are set, then we need to use check using those, which is a It's a bit tricky because the parser needs to start from data inside this thing here. How do I do that in a good way? I sort of need to skip over some stuff, go inside, parse a thing. Token, previous token. Well, this one is quite funny, right? Because it does sort of a similar thing where it steals out a You know what? I'm gonna I'm just gonna try something here. I'm gonna do a funny thing. Else if key is data, then we say we've gone past the colon. Hi, Bill. Thank you. You have to sing while you do stuff, otherwise it won't work. I'm doing fun experiments with the JSON marshal and unmarshalling with how to store the extra stuff. Store like a variant name and a variant tag if you enable a setting on it. But it's a bit of a, I'm just hacking around for now. So here we take this funny extra parser we had here. Oh yeah, this one is not even a, just copy that one out maybe. We have these three things here. Because what we can do now is now the variant name and the tag can appear in any order, and we have the data, and then we're able to sort of look at those to figure out the tag for the union based on these two. And then we can parse the data using this variant parser thingy here. Maybe. Let's just try it with the variant name first. Hi fly sand. If I'm looking at, you know, this thing here, unmarshal uses first struct and union of structs thingy. I'm looking at that and trying to see, like this is the case where it, even though you have B, hello B like this in here, it fits it into A because there's nothing, it could just as well fit into this one, right? Because it's allowed to be missing fields. Like someone could have had a field B in A before, and then it's just like, okay, but I tried A first. That was the first one that was a struct at least, so it fits with these curly braces here, right? So I've been thinking about that a bit for quite a long while now here, and I'm just trying to hack around a bit in. I've managed to. Well, this doesn't compile anymore because I am in the middle of doing funny stuff. But I've managed to take the example in the issue, essentially. So you have your B hello P here, and then you write the variant name and the tag also, if this write union variant info is true. Then it does that. It does it even if it's like a float or something. It will inject this whole struct here. And then I can look, when I come into the marshalling, I can look at this. And in the unmarshalling, I can look at this stuff. I'm like, okay, there was an open brace where I expect the data for the there was an open brace like where I expected the data, in this case here. So then it goes in and starts looking like, okay, is there fields called variant name and variant tag inside this thingy? It sort of starts just parsing ahead a bit. And then it can use those as sort of extra info, right? And if there is no opening brace, then I will try to do what I did before. If it's a F32, we can use parse F32. or if it's just a struct, it will also work. It's just if it finds any of these two funny ones with this impossible, like, because there's a dollar sign here, you can, I don't think you can have, no, you can't have a dollar sign on a variable name, right? Yeah. So I'm just abusing that a bit here to check for these special ones, and then I will go in and parse whatever is on the data as the actual thing it's supposed to be, but then it has the extra info here. And I write both the name and the tag, because it will first, if the name is set, then it will be like, oh, the name is set, cool, I'm gonna use that and try to look in through the variants of the union, see if it finds it, so it can find the tag that it's supposed to use. But if someone has done this, rename B to Bob, then this will no longer work. But then it's like, okay, I had a name, but it was of no use. Then it's like, but I still have a tag, and then it's like, okay, one. In this case, the tag is 2, 1, 2, 3. Oh yeah, because that's how the JSON Marshall writes it. It ignores the nil stuff. So you have 0, 1, 1, 0, 1, 2. Yeah, so that's the 2 is the tag for Bob. So then it can fall back on that one in that case. But yeah, I might continue working on this a bit later because I have to take a break and go and eat and stuff. But there's a bunch of problems. Like here I'm doing allocations because I'm using the built-in stuff in the marshaller. Of course, this is sort of a internal look ahead thingy here. It doesn't need to do any allocations. It can use the string data as it is. So there's needs no allocations at all and stuff. But it should be possible to do sort of a backwards compatible thingy that can write extra data and all that. You just enable it with a bool on the writer, and then other than that everything works like before. We shall see. But I have to go eat because apparently there has been food cooked for me. It sounds amazing. I might do more streaming later tonight. We'll see. It was quite fun to work on this on a stream. Bye for now.